chapter 11, section 1, day 2, actually starts the permutations and combinations that I mentioned a little bit earlier. We'll use a permutation where order matters. So the big idea is that anytime order matters, anytime it matters whether you say one thing first or another thing second, or whether you put places to things, or if somebody can finish first versus second, anytime that order matters, you'll use a permutation. So there are several things you should probably make a note of. Permutations are required anytime you do spelling, or anytime you talk about time, anytime you display something or order it, or I'm going to put places. Then I'll also put the fact that I'm talking about first, second, third, etc. It's kind of like a cheat sheet of when you use permutations. So if you take a look at example 1, you want to arrange your math book, lit book, and chem book on a shelf. And how many different ways can they be arranged? So I'm actually going to use a fundamental counting principle for this one. So you can see there are 3 spots for books on the shelf. I have 3 choices for the first book, but then one of them is used. So then I only have 2, and then I only have 1. If I use the fundamental counting principle, there would be 6 ways for me to arrange those books. This is really a display. Consider the fact that in this case, I'm displaying the books on a shelf. How many ways can you file 12 folders, one after another, in a drawer? So you could do the same thing here. I'm essentially displaying the drawer of all of its folders. So I'm going to use a shortcut here instead. Instead of putting 12 different lines for the fundamental counting principle, I'm actually going to use 12 factorial, because my lines would say 12 times 11 times 10 times 9, because I'm using a folder each time. So take a second, put 12 factorial in the calculator. The answer is rather large. Make sure you put some kind of label behind it, in this case, ways. Order matters here. I'm displaying it. I'm arranging it. So there's a formula for permutation. Technically, what we just did in those last 3 questions were a permutation in which all of the objects were used, but not all of the objects have to be used. There is a formula. It's there for you to see, also on your notes, but I'll show you how to use the calculator instead. So take a look at number 4. In how many ways can 10 runners finish first, second, and third? So 10 people are starting the race, but only 3 of them will get a finishing place. And so this is a permutation. Races, things that have a place, are permutation. So you put a big capital P. You always put how many things you start with for it, and then how many matter when you're done. So 10 people will start, but only 3 will finish. So in the calculator, you'd hit the 10 first, and then hit the PRB menu, and notice the first option says NPR, so you want that option, and then hit 3. You should find it 720. So that means there are 720 ways that those 10 people can finish first, second, and third. Number 5, a band has 7 new songs and wants to put 5 of them on a demo CD. How many arrangements, that's a key word there, of 5 songs are possible? In this case, this is a permutation because I'm arranging things. Order matters. I have 7 to choose from, but only 5 will make it on the CD. So in the calculator, hit 7 first, then the PRB menu, choose the first option, and then 5. There would be 2,520 arrangements possible. You don't need that work. You should have had 8P5, which gives you 6,720, I would say, arrangements for this one as well. First baseman and a pitcher from 9 players means that you're going to do 9P2, which is 72 ways.